Classification of numbers part 1. So you all know like numbers are of two types, real number and imaginary number. In any aptitude exam will be asked question on the real numbers. No question will be from imaginary numbers. So we'll be studying here real numbers only. Real numbers are further classified into two types, decimal numbers and integers. Decimal number are like 1.25, 1.333 till infinite and 1.7213405 random numbers till infinite. So these are the decimal numbers. Integers are like -3, 2, 1, 0. These all are integer numbers. Decimal numbers further can be of two types. Finite are terminating decimal numbers. Infinite are non-terminating decimal numbers. Finite or terminating decimal number are those numbers in which there are limited numbers or limited digits after decimal. So like this is the number, there is only 2 digits after the decimal, so this number will be called a finite or terminating decimal number. Whereas these are non-terminating or infinite decimal numbers. So like you can say this is like here 3 is not. You cannot say like there are n number of 3s. There are infinite 3s after decimal. So this is infinite or non-terminating decimals. These are further divided into two types. First is recurring, second is non-recurring. So here in the example you can itself see here one thing, that in this example 3 is repeating till infinite time. And we can write other examples also like 2.4747. It is repeating till infinite. So in this you can see a pattern. Like here 3 is repeating till infinite. Here 47 is repeating till infinite. So there is a some pattern. So these type of number are called recurring numbers. Whereas 1.721, this example 1.7213405 are some random numbers are repeating till infinite. There is no pattern. Like let's write any other random number. So this is any number will come after that and this goes on till infinite. So these type of numbers are called non-recurring, non-terminating decimals. So for example, you must have remembered like value of root 3 is 1.732 approximate, but after these also are numbers that are like non-ending and also there is no pattern. So these type of numbers are called non-recurring, non-terminating decimals. I hope this part get cleared, like decimal numbers, then these are the two types, then these are the two types. So if you write example, so this is the example, here root 3, root 2 and pi. Pi you all know, like pi, value of pi is 3.14. We know this is the approximate value. After that also there are infinite numbers without any pattern. So these are the non-recurring, non-terminating decimals. Recurring are like where is a pattern. Now let's see the integer part. So in integer there is positive integers like 1, 2, 3, 4, 5 and 0. You all know like 0 is neither positive nor negative. So you can see here like 0 is a different number. It's not positive, it's not negative. So this is a broad classification of your real numbers. Now see like few important points related to your classification. First point, finite or terminating decimals and recurring decimals are called rational numbers. So rational number, definition of rational number is that a number that can be written in P by Q form. P by Q form are called the rational numbers. So you can see here what was written there, that the numbers, that these two numbers, just read this statement, terminating decimal and recurring are called the rational numbers. So these two numbers are rational numbers. What it means, that you can convert this number into P by Q form. P by Q form, this is called P by Q form. You can convert this number into P by Q form. We'll learn the method like how to convert these number into P by Q form. This you already know, like what you'll do, we'll just remove this decimal and we'll put number of zeros here. So this is the p by q form of this number. We'll learn how to convert this number into decimal number. That is the simple method that we'll see in upcoming slides. I hope this part is clear. So these are called the rational numbers. These two are the rational numbers. Whereas non-recurring number are called the irrational numbers. Irrational numbers. So these are the numbers that you cannot convert into p by q form. You cannot convert root 2 into some p by q form. You cannot convert pi into some p by q form. I know you guys know that pi equal to 22 by 7, but this is not exact value. This is the approximation. Fine. Remember this thing. Pi is an irrational number and 22 by 7 is not its form. This is an approximation. Okay. So this second statement is also same that I was explaining, that irrational numbers. Third, non-negative integers are called the whole numbers. Let's see on the chart. Non-negative means this part. This is non-negative. Negative is this one, and the remaining is the non-negative. This is called the whole number. So whole numbers become 0, 1, 2, 3 till infinite. So like these are the 0, 1, 2, 3 till infinite. Positive integers are called the natural numbers. So these are called the natural numbers. These are called the natural numbers. Like counting numbers are your natural numbers 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 counting numbers are your natural numbers. And these are three types, further divided into three types. Unity, that is your 1. 1 is neither prime nor composite, as 0 is not neither positive nor negative. 1 is also not prime nor composite. Prime numbers are numbers 2, 3, 5, 7. We'll see the definition of prime numbers, and also we see how to find a number is prime or not in upcoming slides. Composite numbers, your numbers like 6, 4, 8, these are all composite numbers. Fraction. So a fraction is a number that is written in the xy form, x upon y form, and like this is called a fraction. When a number is written in this form, this is a fraction in which y cannot be 0. Y cannot be 0. And these are further classified into two types, proper fraction and improper fraction. When value of x, this is called the numerator and this is called the denominator. When the value of numerator is less than denominator, this is called a proper fraction. And this is called improper fraction when value of numerator is greater than the denominator. For example, this is a proper fraction, whereas this is a improper fraction. So fraction and improper, this thing is clear. This is an important point. Make sure you like pay attention here. Finite are terminating decimal numbers. Let's see on the chart what was this thing. This is this part. Finite are terminating decimal number. Decimal ka like two parts are there. So this is the part. Finite are terminating decimal numbers. And important part is like suppose this is the number. This is the number. This is finite are terminating decimal number. When you convert into p by q form, this become like this. Right? Any finite are terminating decimal number. Let's say this is this again. If you convert, you will get this thing. If you convert like 1 by 3, so you will get 13 upon 10. So one thing here to pay attention, that 100 is a combination of 2's and 5's. 2's and 5's. 100 is a combination of 2's and 5. 10 is a combination of 2 and 5. So whenever this is written here, these numbers have only 2's or 5's, or combination of 2's 5 in the denominator. तो जो तुम्हारे फाइनाइट और टर्मिनेटिंग डेसिमल नंबर्स होते हैं उनके डिनोमिनेटर में you'll always get either 2 or 5 or any combination of 2, 5. Like suppose this number is written. Suppose this is mentioned. And let's say like we can take different also NP. So NP are integers. NP are integers. Let's say to simplify the things, let's take positive integers. Positive integers you all know are natural numbers. These are the positive integers are natural numbers. Then this number gonna be always a terminating decimal number because there is a combination of 2 or 5. If there is other number, like suppose this was 7 2 to the power n into 5 to the power p. So this number will not be a finite or terminating decimal number until unless n is a multiple of 7. Until unless n is multiple of 7. I hope you guys are able to understand this thing. Let me just simplify it. You need to remember this thing. In finite or terminating decimal number, in the denominator part, you'll always get 2, any combination of 2, 5. Any combination का मतलब है there might be only 2, there might be only 5, there might be 2, 5, like something like that. Any combination of 2, 5. I hope this is clear. So this question is related to this particular concept. So what you need to do, you need to like mark this question, because in this question a concept of factors will be also involved. So you have to mark this question, take a screenshot, note down this question, and you have to solve this question. I will be explaining this question in the your when we'll be covering the factor part. Prime numbers. So you all know like prime numbers, definition of prime numbers, if you see simple, prime numbers are those numbers that you cannot divide with any number. And a prime number is divided by itself or by a 1. And 2 is a prime number, so this will be divided by only 1 or 2. So या फिर खुद से डिवाइड होगा या फिर 1 से डिवाइड होगा. It will be not divided by any other number. Or you can say prime number will have always 2 factors. तो इसका देखो 2 फैक्टर है, 1 and 2. So this is the definition. This is the like way to identify a prime number. Any prime number, note down this thing. Any prime number can be written in 6n plus minus 1 form. Any prime number can be written as in 6n plus minus 1 form, where n is a positive integer or n is a natural number, you can say. And condition is greater than equal to 5. This will be started with the 5 है ना. 5 से नीचे 2 और 3 पे applicable नहीं होगा. This is started greater than equal to 5. But vice versa is not true. What I am going to say, like let's see there is a number. Let's say there is a number 25. 25 also can be represented in this form. 25 can represented in this form, but 25 is not a prime number. So what it means that a prime number can be expressed, can be written in 6n plus minus 1 form. A prime number can be written in 6n plus minus 1 form, but any number that can be written in 6n plus minus 1 form may or may not be a prime number. May not be a prime number. This statement note down कर लो. I hope this thing is clear. So vice versa situation is not valid here. I shown the examples also. Now how to check a number is prime or not. So let's take an example like 137. So I'm going to tell you complete algorithm how to check a given number is prime or not. And we want to find that this is prime or not. The first step is take the square root of the number. The square root of this number will be like, this is between 11. You don't need to find the exact, you just find the approx. So in between 11 and 12. Now you need to take this number, take the highest number, and you need to check. So this was the first step. You need to find the approximate square root of the given number and then take the higher value, that is 12. Second step, write all the prime numbers that are below or 12 itself, below 12 or the number itself. Suppose this number was 17, so we'll include the 17 also because that is a prime number. So those prime numbers will be 2, 3, 5, 7 and 11. These are the prime numbers. Now, third step, you need to check if 137 is divisible by any of these prime number. So this is not divisible by 2. This is not divisible by 3 also. We'll also see the how to check the divisibility rule. We'll see the further sessions. But right now, I'm expecting whatever thing you can use, just use the thing. 7, it is not. 11, it is not. So that's why this is a prime number. This is a prime number. So steps are, first find the square root, approximate square root, then take the this part. This we also call, we can say, lowest integer, and because this will be 11 point something, so lowest integer is 12. Then second step is write the prime numbers below are including this number. Then third step is to check the number 137 is divisible by these prime numbers or not. If it is divisible if it is not divisible by any of these prime numbers, then the given number is a prime number. अब suppose if किसी number से divisible हो जाता, then this will not be a prime number. This is clear. These steps are basic 3-4 steps. I hope you are able to understand. This is the question that you need to find the number of prime numbers below 1000, that are 168. So there are 168 prime numbers below 1000. So you need to just remember this thing and nothing else. I'm going to tell you a few things that you need to remember, that from 1 to 50 and 50 to 100 and 100 to 150 and 150 to 100. So this will be useful when you are solving the questions. You can solve the question faster. So there are 15 prime numbers between 1 to 50, and there are 10 prime numbers. There are 10 prime numbers between these numbers, and there are 11 prime numbers. So remember this thing. So total 25 prime numbers, 1 to 100, total 21, and to total 46 prime number are there from 1 to 200. So remember this table in this division form, 1 to 15, 15, 10, 10, 11, then 25, 21, and total 46. This will help you to solve the question. So twin prime numbers and triplets. So first let's talk about triplets, then we'll come to the twin prime number, because that will take a little time, and triplets are very simple. So triplets are those numbers, those prime numbers basically, that has a gap of 2, like 3, 5, 7. This is a gap of 2. So this is a triplet. So there exists only one triplet. There is only one triplet, 3, 5, 7. Sometimes this may mention in the question, so that's why you need to remember this thing. There is exactly only one triplet, that is 3, 5, 7. Twin prime numbers are those prime numbers, pair of prime numbers, there is a gap of 2, like 3, 5, 5, 7, 11, 13, 17, 19. So there are so many twin prime numbers are, but triplet is only one. I hope you will remember this part. So in the starting of the prime number, I have told you one thing. I have told you, let's discuss further twin prime numbers. I have told you that a prime number can be written in 6n plus minus 1 form. So what is the difference between this 6n plus 1, 6n minus 1? If you see, difference between these two numbers is 2. 2 का difference है. 2 का difference है. So suppose I ask you question, find the, suppose this is the question, find the twin prime numbers below 100. Suppose this is the question, find the twin prime numbers below 100. What you will do? You'll use this thing. You'll use this thing. So first, this is valid for greater than equal to 5. So below it, 3, 5. This you'll write. And after that, you will use this thing. I just put 1 here, so I got 7. I will put 1 here, so I got 5, 7. This is the twin prime number. Then you put 2 here, so that is 12, 1, 13, and 11. So this is 11, 13. So this way you will get all the twin prime numbers. So this question, I just solve this question. Let me know answer in the comment section. Fine. I hope you will be able to solve this. This thing is clear. And the last part regarding prime number, some basic properties I hope you already know, but let me just. So smallest prime number is 2. 2 is the smallest prime number, and 2 is the only even prime number. 2 is only even prime number. Only even prime number. 3 is the smallest odd prime number. 3 is the smallest odd prime number. Basic things, you all know this thing already. So co-prime numbers, let's discuss. So co-prime numbers are those numbers, like prime numbers are the numbers, those are not, like they are divisible by only the number itself or by the 1. But co-prime are those numbers, like these are the pair of numbers, like let's write any number, let's 24 and 25. Let's write very simple two numbers. So these numbers are co-prime. Why? You can see here 25 is not a prime number, 25 is also not a prime number. But if you write these two numbers together, these numbers will called be a co-prime number. So co-prime are those numbers, those pair of numbers are like three numbers. This can be also three number, five numbers, or n number, like 24, 25, and let's write 23. These are also a co-prime numbers. Basically, when the HCF of numbers is 1, HCF of pair of numbers are n numbers for which HCF is 1, those number will called be a co-prime numbers. Fine. So जो numbers तुम्हारे होते हैं जिनका HCF, for those HCF is 1, those number will called be a co-prime number. Number itself may or may not be a prime number. And one thing, two consecutive numbers, note down this thing, two consecutive numbers will always be co-prime numbers. Two consecutive numbers will always be co-prime number. Always be co-prime. Co-prime are also called as relatively prime, or relative prime, or relatively prime numbers. Relatively prime numbers. So this was about the co-prime numbers. So composite numbers. Composite numbers are like, so in the starting I have told you that natural numbers are unity and prime numbers and composite number. Unity was your 1, and the prime numbers were the numbers like 2, 3, 5, 7 that are not divisible by any number, only by number itself and 1. And the remaining numbers are the composite numbers. Remaining numbers like 2, 3, 4, 6, 8, 9, 10, 12. These numbers are the composite numbers. Basically, composite numbers have like factors more than, like इसके 2 factors होते थे, they will have more factors. So remember this thing. These are called the composite numbers. So there is no as such like a thing to remember, just the basic things that you need to know, that these are the composite. Perfect number, one important thing, perfect number are those numbers, like let's I will explain you with the help of example. 6 is a perfect number. So if I write all the factors of 6, so these are the factors of 6, and if you add all the factor of 6, you'll get 12. And this is the choice of this number. So this is the property of perfect numbers, that they will be, sum of the factors of the number will be twice of the number. So you can write this thing. If the sum of the factors, of number equal to twice of number itself. So like suppose number is n. If this situation is satisfied, then the number will be perfect number. Or you can say one more thing you can observe here, that if I remove this thing, if I remove 6, so this will be equal to 6. Right? So in some books or somewhere you will also get this thing, that if the sum of the factors excluding number that is equal to the sum of the numbers, those numbers are called the perfect numbers. So if you exclude 6 here, you'll get the sum 6. So in some books, you'll get this definition also. This is also fine. There is no issue. Now digital root not part of classification, but this is a concept. I will be needed to explain it because I have to explain perfect square numbers. So digital root basically is the sum of the digits of a number. Like let's write 13. So sum of digits is 1 plus 3, that is 4. So this is the digital root of this 13. And let's say like other number is 127. So digital root of this will be 1, 2 plus 7. So that is 10. And 10 again, 1 plus 0, that is 1. So basically you need to reach at the end. You need to reach at the end when the sum of the digits of the number become a single digit number. This is called the digital root of 127. 1, 2, 3, 4. Digital root of this will be like, let's take 9. So this is 9. 1 plus 2 plus 3 plus 9. So this is 15. And again 1 plus 5, that is 6. So 6 is the digital root of this number. One thing you can also do, you can remove 9. Don't count 9. Wherever 9 is there or any number is making 9, just remove that. So just add these number, that is 6. So 6 is the digital root of this number. This is the shortcut that you can use. Suppose you have to find the digital root of this number. So I will add 7 to and I will remove because this is making 9. The digital root of this is 1. Right. So now I hope understood what is the digital root. So digital root is basically the sum of the digits of a number to the in the form of a single digit. So that is the digital root of a given number. Okay. So let's come to this part. Perfect square number. Perfect square number are those numbers, the square root of those numbers is a integer number like root 4. 4 is a perfect square because the square root of 4 is 2. 16 is a perfect square because square root of this is 4. So definition of perfect square number is clear. Now let me just explain this point. So this is written 1497. You can like remember it like 1947, I think. You can remember it like 1947, the year we got independence. So what it means, so any prime number, you not prime number, you take any perfect square number, digital root of that number will be either 1, either 9 or 4 or 7. Fine. If there is a perfect square number, then the digital root of that number must be either 1, 9, 4, 7. Digital root of any perfect square number cannot be 8, 5, cannot be 6, cannot be any other thing except 1, 9, 4, 7. But vice versa is not true. That the same case I have told for 6 and plus minus 1 form is also valid here. Any number satisfying this may or may not be a perfect square. Fine. So make clear this thing. This vice versa is not valid. If there is like 25 is a perfect square number, so this must satisfy this thing. This is satisfying. Digital root is 7. But any other number, let's say 61. 61 is satisfying this, but 61 is not a perfect square number. So remember this thing. Any perfect square number will always have digital root among 1, 9, 4, 7. But a number having this digital root may or may not be a perfect square number. So if you want to check a number, like if you want to find that 36 is a perfect square or not, the digital root is 9. So this may or may not be a prime number. But suppose you take a number, let's say you take a number 35. So digital root is this 8. So now you can conclude that this will not be a perfect square number. So this first part regarding your perfect square number is clear. Now let's see the second statement, or you can say second property or second way. Product of any 4 consecutive number. Let me just remove all these things. Second part, product of any 4 consecutive number plus 1 will be always a perfect square number. Let's take any example, 2, 3, 4 and 5 plus 1. This will be a perfect square number. So that is 10 and 120 and 121. So 121 we know is a perfect square. Root of 121 is a 11. So remember this point and remember this thing. Now let's see what this table, what this chart is like here. So with the help of this, like any perfect square number will always have last digit as 0, 1, 4, 5, 6, 9. Any number ending with 2, 3, 7, and any other left 4, 5, 6, 7, 8 cannot be a prime number, cannot be a perfect square number. Okay? Not prime, cannot be a. So any number ending with 2, 3, 7, 8 cannot be a perfect square number. Like let's write any random number 142. This will not be a perfect square number because this is ending with 2. Numbers ending with either 0, 1, 4, 5, 6, 9 may or may not be a perfect square number. So this is for the last digit, and there is also situation for the second last digit. So if a number like is ending 650, if a number is ending is 650, then at tens place, at tens, if a number is ending with 6, tens place must be a odd digit, like 36. And this thing is again also vice versa is not true, like 56. 56 is not a perfect square number, right? If a number is ending with 6, then tens place must be odd number. Suppose 46, so this will not be a, we can conclude that this is not a perfect square number. But if it is 56, we cannot conclude, but we can say this may be, there is a probability that this may be a perfect square number. For 5, if a number is ending with 5, then tens place must be a 2 if in order given number to be a perfect square number. For 0, you need to be 0. For if a number is ending with 1, 4, 9, the number before that at the number at tens place must be a even number in order to given number to be a perfect square number. I hope these 3 points regarding perfect square number is clear. And the remaining part of the classification of numbers will be doing in the second part.